Keeper 4.4, derivatives of trig functions. All right, so here are our formulas for our derivatives. These formulas definitely need to be memorized. You need to know them like the back of your hand. So the derivative of sine is cosine, whereas the derivative of cosine is negative sine. The derivative of tan is secant squared, and then the derivative of secant is secant tan. We have the derivative of cosecant is negative cosecant cotan, and then lastly, the derivative of cotan is negative cosecant squared. I know it might seem like a lot to remember, but I will give you one trick. Whenever you see the derivative of like a C word, so like cosine or cosecant or cotan, your derivative is always going to be negative. All right, so again, anytime that you see a derivative of a C word, your derivative is going to be negative. Other than that, you kind of just need to memorize the rest of it. But again, a lot of students mess up because they forget when to put the negatives versus positive. If you take the derivative of a C, make sure that the value is negative. So let's look at some examples. The first example we have is f of x equals sine x times cosine x. We definitely have to use the product rule because I'm multiplying. So using the product rule, I'm going to rewrite it as f prime of x equals first, which is sine x, times the derivative of the second. This is the second. I need the derivative of cosine, which from our formulas is negative sine x, plus second, which was cosine x, times the derivative of first. The derivative of sine x is negative cosine x, or sorry, cosine x. So cleaning that up, I get negative sine squared x plus cosine squared x, or cosine squared x minus sine squared x. And then using one of my trig identities, I recognize that this is cosine of 2x. All right, another example. Again, I'm multiplying in this example. I have x squared times cosine x, so I must use the product rule. So I have f prime of x equals x squared, that's first, times the derivative of the second. The derivative of cosine is negative sine x, plus second, which is cosine x, times the derivative of the first, which is 2x. Cleaning that up, making it look pretty, I get negative x squared sine x plus 2x cosine x. All right, next we have cosine x over x sine x. I could choose to try to clean this up first, but I'm just going to take the derivative as is. So I have f prime of x equals, and notice that we're dividing, so we have to use quotient rule. So I'm going to start with low, which is x sine x, d high, so the derivative of cosine is negative sine, minus high, so minus cosine, times the derivative of the low. Now the derivative of the low is product rule, so I have to do first times the derivative of the second, which is cosine, plus second sine x times the derivative of the first, which is 1, all over low, which is x sine x squared. From there, I'm just going to start simplifying. So I'm going to distribute, I'm going to add like terms. I get negative x sine squared x minus x cosine squared x minus sine x cosine x. Again, I think I could simplify this a little bit more by factoring out negative x in my numerator for my first two terms. So I get negative x sine squared plus cosine squared minus sine x cosine x. Now using Pythagorean identity, I know that sine squared plus cosine squared is 1, and I'm left with f prime of x equals negative x minus sine x times cosine x over x sine x squared. All right, last example, we have f of x equals x minus 4 cosecant x plus 2 cotan x. Taking that derivative, I'm going to take the derivative of x, which is 1. Then I'm going to take the derivative of cosecant x, which is negative cosecant cotan. Notice I left the 4 in front since it was just a coefficient. And then lastly, I'm going to take the derivative of cotan, which is negative cosecant squared. But again, I'm going to leave the 2 in front. Now when I clean this up to make it look nicer, I'm going to have 1 plus, because I had 2 negatives, 4 cosecant cotan, minus 2 cosecant squared x.